So lesson 7 talks about solving exponential equations. Now I'm going to add something in here using same base or different bases. Right? So some things we can make the same base, some stuff more difficult. So it says here, use the following tips to solve exponential equations. Convert the same bases and combine if possible and solve with the same base technique. That's one approach. Now, if we can't convert to the same base, okay, if we can't make them all the same base, then we have to use logarithm strategy, which was discussed yesterday. So, let's take a look. Here. I said earlier here, this one we could be the same base. This is base 3, this is base 9, but 9 could be changed to 3 squared. So it's going to be 3 to the exponent 2 minus 8x equals to 9. How do I write 9? 3 squared to the power of 3x plus 1. Okay. Now that the bases are the same, for this to be equal to each other, the exponents have to be the same. The exponents now must be equal. Okay, well, if they're equal, then it's going to be 2 minus 8x equals to 2 times 3x plus 1, yes? Okay. Then from here, it's a matter of solving for x, isolating the variable x. So 2 minus 8x equals to 6x plus 2. Okay, I'll go over here. This is going to be 2 minus 8x equals to 6x plus 2. I bring the 2 over to the other side. That becomes 2 minus 2 equals to 8x plus 6x. 0 equals to 14x. Therefore, x must be equal to 0. So if this is 0, if x is 0, let's see if that makes sense to us. If x is 0, look at this. It's going to be 3 times 0 is 0. So we're going to be left with 9 to the power of 1, which is 9, right? Over here, if x is 0, 8 times 0 is 0. What's left is 3 squared, which is also 9. So 9 is equals to 9. So x equals to 0 is a solution. Take a look at B. Now this one here, you can make this the same base if you want, or 4 to the x minus 2. Okay, how can we make this the same base? 4 to the 0. 4 to the 0. Because anything to the power of 0 is 1, right? So now that the bases are the same, it's up to the exponent to make the left side equal to the right side. So therefore, x minus 2 equals to 0. This is an easy one. So x is equals to 2. Okay, so let's see if that makes sense to us. You put 2 back there into our equation. It's going to be 4 to the exponent of 2 minus 2, and then 2 minus 2 is 0. 4 to the 0 is 1. So yeah, that's good.
How do you get the power of 0?
How did I get to the power of 0 here? Because anything to the power of 0 is equals to 1, right? This one. Yeah, what we're going to do is like this one here, how can we make them the same base we're going to use the base 10. But this one, the 10 is in the denominator. It's been reciprocated. And to deal with the reciprocal, this is the same thing as 10 to the negative 1. Because 10 to the negative 1 is 1/10, right? 10 to the negative 1 to the exponent 4x equals. Now, what would this be? 10 to what exponent will give you a million? 10 to the 6. Okay? So that means,
Count the zeros?
yeah, count the zeros, yeah. Now that the base are the same, it's up to the exponent to make the left side equal to the right side. So you get, so therefore, negative 4x is equals to 6. That means it's going to be divided by negative 4. It's going to be negative 3/2. Okay. Good. So that one's not so bad, right? Because we can make the bases the same. So that's one strategy. Okay. Huh? Can we verify? Yeah, sure. Okay. So this becomes 1/10 to the power of 4 to the negative 3/2. Okay, so that's going to be 1/10. That's going to be, you cancel, so that's going to be negative 6, yes? How do you make this to a positive exponent? Reciprocate. To make the exponent positive, you're going to reciprocate the base. So that becomes 10 to the 6. Well, what's 10 to the 6? Million. So it is the same. Okay. Good. Now this is when, now we're entering a stage here where no matter, it's not going to be a nice number here, because 2 to an exponent, it's not a nice exponent, will give us 55, right? So, okay, I won't do that one right now. We're not going to do trial and error in here because that's so inefficient, right? So, how can we do this? What we're going to do? What we're going to do is we're going to take the log of both sides, okay? So, log of both sides. And we can operate with base 2, because the 2 is the base here. So log 55 base 2 is equals to log of 2 to the x plus 1. Okay. So how can we apply some logarithm here? We can put this at the front, right? Power to a power. So it becomes log of 55 equals to x plus 1 times log 2 base 2. Okay. Now let's see here. What can we do? We're trying to solve for this x here. Have it alone. But we can't because this is inside the brackets. So what we could do is we can multiply it in. Oh. Okay, I'm going to keep my base 2 here. So if I multiply it in, it's going to be log 55 base 2 equals to x log 2 base 2 plus 1 times log of 2 base 2. Which one? We will get to that one. Which one are you, this one? This one? Yeah, oh, yeah, we could do that too. Like we can officially make it 1, right? Yeah. I could do that right away. It's equal to 1. Okay. Okay. So from here, we've expanded and then we say, okay, this is going to be log of 55 base 2 equals to, if you look at this one in here, log 2 to what exponent will give you 2? 1. So this is just going to be x. Plus 2 to what exponent will give me 2? 1. Okay, so far we're getting close to having the x alone. So bring this to the other side, that becomes what? It's going to be log 55 base 2 minus 1. Now, this one here, last time we said we can't put that into our calculator and figure that out, right? So what we have to do is we have to apply a change of base to do that. So, what would it be? What's the change of base again? This is the same thing as log 55 divided by log 2 minus 1. Which one?
Wouldn't be log 55 base 2 divided by...
No, we're changing the base. We're now changing the base as base 10. Yeah, because the only thing that we could do using a calculator is either log or natural log, right? Which is log as base 10. So yeah, let's go ahead and figure that out. Log 55 divided by log 2 minus 1, so 4.781. So that means the exponent must be not the exponent, the x must be 4.781. Okay, let's see if that makes sense to us. Let's see. We're gonna go 2 to the exponent of 4.781, and we realize that we're not typing all of them, right? So plus 1. We're not going to get exactly 55 because we didn't really write down all of the decimals here, but that's pretty close to the 55. Yeah?
I also have a question. This is related to one of the questions in the slide you put up yesterday. It's the trial and error one. You want us to just go until we more or less reach as close to that value as possible? Because I have been able to get to like, one of them is like, you have to get to like 10, and I've been able to get to like 10.0001 or something like that.
Okay. If it says trial and error, systematic trial and error, then it has to be systematic trial and error.
Right.
Yeah.
But
so
to
it's-
as close to...
yeah, as close to the number you're gonna get.
But once we hit that, we can just end, like once we say we get like 10.0000, we don't have to like try again if it's like a little
More?
a bit closer to it, right?
No, yeah. It's gonna be very hard to get to the exact 55 for this one. Yeah. So that's why sometimes it's on the On the assignment, if it's like a systematic error, write it as like up to like 3 decimal places. Yeah, that's okay. Okay, that's good. Yeah, I got a question. Fu? Oh, on your calculator? Oh, how to type it in? So you can look at your calculator. Mine is over here. Do we have the same one? Okay. So you go second function log, second function 1, and that will give you the log. Yeah, 55 divided by second function log 2. And then that will give you this part here, right? And then minus 1. 4.781.
What is the ENG button?
Where is that?
I have the ENG and RC.
Yeah, I'm not sure.
It doesn't do anything when you press
Or
it.
recall, I guess. Recall? I'm not sure. Okay. Any other questions? Yeah? Okay, now let's see here. Here, this is a base 7. Is a 2 a base? No, because there's not applied to, yeah, it's a tricky question, right? So the base here is 7, and can we make this base 7? No, right? So what we can do is try to solve for that. Okay, so here we go. Because this is 2 times something, we can just divide by 2. That will make it a little bit better, a little bit easier in terms of numbers. Okay. So 7 to the exponent x minus 2 equals to 50. Now, how can we get the exact, or not the exact, but approximate value of that? This is actually not bad. So I can actually see that it's going to be about 4, right? Do you see why it's 4? Because 7 squared will be 49. Okay, 7 squared is 49. So how can I make this squared if this is 4? 4 minus 2. So it's going to be, x would be approximately 4. Okay, so now 4 point something something. So how do we go from there? What are we going to do? Take log. Yeah, we're just going to go straight to log base 10 instead of base 7. So it's log of 7 x minus 2 equals to log of 50. Okay, so if we take the log of that, then we don't have to worry about changing the base later. It's right now log b with the base 10. So apply the logarithm rule. So this exponent will go to the front. So this becomes x minus 2 log 7 equals to log 50. Okay, this way. So how do we do this? It's going to be, let's expand this in. It's going to be x log 7 minus 2 log 7 equals to log 50. This is my x here. I can bring this over to the other side. So this becomes just x log 7 equals to log 50 plus 2 log 7. So if you want, we can continue on with this, or at this point you can type it into your calculator. But let's go ahead. Let's see if we can simplify further. This is going to be 50 plus log of 7 squared, which is like that. You okay? So this will be written there. So 7 squared. So this is going to be log of 50 times 49. Right? So let's see, what's 50 times 49? 2,450. You get 4. 50 times 40. Yeah, 4.010, right? Let's see here. Did you type it from here?
I just know that the 7 is 1, and the 50 is below 50 divided by 7, and the up, that is around.
Okay, hold on.
Yeah, but that's
I have 2 different ways. I don't know why that one is not working for me. This is my original notes.
That's what I wrote.
Did you change of base? It should work that way too. You got 4.00. And I'm trying a different way.
Different base?
Okay. Gotta take a look at that one, why it's not the same. Okay.
Do you have a base 7 there?
Yeah, like this one here, I'm using a different strategy with base 7 and then I did a change of base here. Okay, let's try that. Gotta go back and take a look why that's not working for me. Yeah. Okay, let's try it again. It should work. I don't know why that is not. Okay, let's try it again. I'm gonna keep it as base 7. It's about 4. Now it's gonna bug me. Okay, now bring this over there to the front. This becomes x minus 2 log 7 equals to log of 50 base 7. Okay. Now log 7 base 7 is just 1. So this is just the value of 1. So it's going to be log of x minus 2 equals to log of 50 base 7. Now this one here is a little bit different. Well, not a little bit, but we don't have a button for this. So we're going to do a change of base. This is going to be x minus 2 is equals to log of 50 over log 7. and then bring the negative 2 over to the other side. That becomes log 50 over log 7 plus 2. Now it's bugging me why that's not the same. Let's see. Now this is better. 4.010. Now that one makes more sense.
I mean, I got the same answer.
Earlier?
Yeah.
Even with the typing?
Wait, what?
Earlier?
Well, just when we stood with log, like when we didn't start with log base 7. Like when we just kept that as
When we kept it the way it is, you got 4?
I got 4.0 into.
Really?
Like
What
you
am I
mean
typing
log
wrong?
2, you mean like a log 2, 2,450 divided by log 7? Yeah, that's right.
Really?
Yeah.
Why, how come I didn't get that? Huh.
2,450
2,004.
divided by log 7. No, 4.010.
Oh, okay. 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 I don't know. Okay. Okay, good. I'm glad it worked. Okay. Good. Awesome. Now let's take a look at this one. Oh my goodness. Can we make this the same base?
No.
No, not possible. So the only possibility would be to take the log. Okay, I'll do log 5 to the exponent 3x minus 1 equals to log base 5 of 45 to the negative x. Okay, let's see. Let's bring this down this way. It's going to be 3x minus 1 times log of 5 base 5 equals to negative x log of 45 base 5. Okay. Now log of 5 base 5, that's just 1. So we're just left with 3x minus 1 equals to negative x log of 45 base 5. Now we're going to bring the one with the x's on one side and then the one with just the number on the other side. So it becomes 3x plus x times log of 45 base 5 equals to 1.
Wait, so we don't do 3x log 5 base 5 subtract log 5 base 5.
Oh, this one here, multiply it in? Yeah. You could do that, or we could simplify it from here.
Oh, okay.
Right away. Yeah, the previous, yeah, it's just 1.
Oh,
Yeah, because this one here, the value is 1, right? Yeah, we could do that and then expand it, and then it's going to be times 1 anyway. Okay, so far so good. Any questions up to this point? No. Okay, so how can we have the x alone? Well, we can't really combine these two together, right? They're not the same term. They're not even the same. This is 3x and this is x log 45, base 5. So how can we do this one? Thinking is to factor out the x, So if you factor out the x, what's left inside? 3 plus log of 45 base 5 equals to 1. Every time I think about this, I always have like different ways of doing things. Okay, so that means x is equal to 1 over 3 plus log of 45 base 5. So it's going to be 1 over 3 plus. Okay, so how can we do this one here? Log of 45 base 5. This one we have to do a change of base. What would it be? What's that? Oh, okay. So you go log 45 over log 5. Okay, now it becomes like this, right? We could go ahead and type that in if you want. Or you can say, hey, this is going to be 1 over, how do I want, 3 log 5 plus log of 45 over log 5. Are you okay still? So if we add these two, they have to have the same denominator. So I had to multiply by log of 5 and then okay. This is a totally different approach compared to my other notes, but let's see what kind of number we're going to come up to. Does everybody have an answer button on their calculators? Yeah? Okay. The answer button? Like answer button? Everybody has one, right? I think most calculator now has answer button. So this is how I would approach. You don't have an answer button? Second function equals? No? Can I see? Okay. So what I would normally do is I think you can store and then do a recall. Okay. Or what you can do is you can just do the brackets. Okay. If not, then just go log 5 divided by, we're going to divide all of these. So brackets 3 times log of 5 plus log of 45. Yep. 0.18638. So did you get this one? The same number? Was that? Okay, sorry, one at a time. I can't. What was that question? Instead of doing all that, you can just go. You can just, yeah, you could. Well, you gotta do a change of base here, but up to here, yeah. Okay, I'm sorry. Where are we looking at? This one? This one? Yeah. Yeah, that's possible. You can go many different ways of doing this. Like if I show you this, right? And if I show you my other way, every time I work out this type of question, I have I always have different ways of doing. So what Johannes was saying is it okay? Yeah. To do it from here already, right? Instead of doing it later on, right? Because we did it, you're thinking of doing the change of base here, and then I did my change of base way out here. So yeah, that's a possibility. You could go, okay, I'm gonna pick it up from here. And we got the same answer? Yeah. So your change of base is happening here. That becomes log of 45 over log of 5. And then, what did you do? You multiply each one by log of 5?
Log 45 divided by log 5 is 2.365 by x.
Oh, okay.
X's, I forgot the
Yeah. Okay, so you evaluated this, which gives you a number. And then you multiply with the negative x, and then you took out the negative 3x, and then you divide that whatever with negative 1. Okay, we get the same answer. Lots of possibilities. I find that you can go tangent on this, but we're gonna get the same thing. Yeah. So yeah, that's a possibility. Do a change of base here. You change your base there. Okay. So take a quick break, okay, and then I'll finish up the last two, and then we'll do that last examples.